Hey everyone, for today we're going to look at something a little bit new called internal energy. It's not something we're going to go too crazy with. It's something we'll show you. So kind of a quick lesson on what this is and kind of how it works. So let's take like number 36. I forgot to ask a question with it, but we'll just kind of talk about it. A car traveling down a straight level road applies its brakes and comes to a stop. So what I want to talk about is sort of the energies that we have here. So we've got a car. It's on a straight level road, so that line's supposed to be flat. Car's going this way, and then eventually it comes to a stop. So eventually, at some point, it has a stop, which means it has a speed of 0 meters per second. Okay, let's talk about our energies here. Let's talk about the potential and the kinetic. So one thing that we said in the last lesson is that energy is what we call conserved, which basically means that if you have a certain amount of energy to begin with, you have the same amount to end with. And the reason that works is if you lose one energy type, you gain another one. So for example, if we lose potential, we gain kinetic. That way the whole thing is the same. Or if we lose kinetic, we gain potential. So that way that whole thing is the same. But let's look at this example because it seems to sort of violate that idea. Car travels down the road, applies its brakes, and comes to a stop. Let's talk about what happens to the potential energy. Alright, does it go up, go down, or stay the same? I would say that the potential energy stays the same because it's on a level road. It just means like a totally flat road. It's not going up, it's not going down. It's perfectly flat. The kinetic energy, well, we're slowing down and stopping. So I would say that that decreases or gets smaller. And the reason that this is kind of a problem, based on what I told you in the last lesson, is that, alright, one's going down, the other's the same. That doesn't make sense, because we said if one goes down, the other has to go up. That way the total would remain constant. But this one, the kinetic is going away. And where is it going? It's not turning into potential, because we said here that that has to be the same. So what's it turning into? What it's turning into is something that we call internal energy. There are a couple different ways you can think about this. For our purposes, it's going to basically be energy that is lost by the system. So it's energy that is lost by the system. By system, I just mean like the objects. And I put lost in quotes because it's not that it's like lost. It didn't go away, it didn't disappear. We did say that can't happen. It's not how it works. So when it's lost, what it actually turns into is it turns into heat energy. So that's another way that you can think about it. The energy sort of goes away, but it doesn't go away, it turns into heat. Like one example, I think you guys brought it up when we did friction, is like when you rub your hands together, you can feel your hands getting warmer, and you're like, that's an example of friction. Really what that is it's friction generating internal energy, or heat energy. All of that rubbing that you're doing, it's not actually accomplishing anything. All the energy is sort of getting lost, and it's lost in the form of heat. So it just turns into some sort of warmth, or some sort of heat energy. And that's what internal energy is. It's energy that's gone now, turned into heat. In science, we call it internal energy because heat is sort of housed internally in the molecules of the object. You may remember from chemistry that heat is just like these sort of like moving around of molecules which are inside of the object. So we're going to use the phrase internal energy quite a bit, but what it really represents is just kind of this heat idea. So let's try a couple of these. For 37, a car has a total of 10 joules of energy at the top of a ramp and only has 6 joules of energy at the bottom of the ramp. How much internal energy was developed in this process? So let's think about this. We've got a car at the top of a ramp, that's a car, and it goes to the bottom of a ramp. Here it has 10 joules of energy. I didn't tell you the type, so let's just assume that's its total energy. At the bottom, it only has 6 joules of energy. Now I want to know the internal energy that's developed, which remember is just like a different way of saying the energy that's lost. Well, we start with 10, we end with 6. How much lost or got disappeared? How much got lost or disappeared? Well, I would say that 4 joules got lost. And where I'm getting that from is, well, we've got 10. We ended with 6. What's the difference? How much is left? I just subtracted them, and I figured out that 4 joules is gone or missing. So that turned into like heat. It warmed up this object. Probably not a lot. It's not going to like burn you if you touch it, but contributed to the warming of this object. Alright, a car applies brakes and comes to a stop on a straight level road. What happens to its kinetic energy? Well, if it comes to a stop, that kinetic energy must have decreased or went away. But that's kind of only half the story here. Decreased. Because energy doesn't go away. That kinetic energy, it's not gone now. It turned into something. It turned into internal energy, or heat. Oh, God. And this is actually something that can happen for cars, is those brakes can get very hot. If you like travel down a long hill or something like that in your car and you ride the brakes the whole time, you can end up with like brake discs that are like glowing hot. They could actually like burn you if you touch them, because it's just a lot of energy in the car turning into this heat energy. So we're gonna do to kind of wrap this up. We're gonna revisit our skateboarder from last time, but what we're gonna do is we're gonna add internal energy. So here, our graphs are a little bit different from the previous lesson. We've got potential and kinetic, and then we're adding this Q. Q in science is the symbol for like heat or internal energy. And then ET is still going to mean the total energy. So let's go. A 100 Newton skateboarder has 400 joules of potential energy and 0 joules of kinetic energy at the top of the ramp. And now we're not going to neglect friction. We're not going to, pretend that there's no energy lost here. So we've got 400 joules of potential at point A, at the top of the ramp. So at point A, I'm going to fill in all 400 joules. We've got no kinetic, all right, 0 joules of kinetic energy, I told you, so we're going to leave that as 0. And that's a total of 400 joules of energy. That's our starting point. Now at point C, which is right here. Alright, I'm going to give you a little bit of extra information to help you answer this, because we just need to know more information to figure out that internal energy. So at point C, the skateboarder has 100 joules of kinetic energy. Alright, so the kinetic energy is 100 joules. Let's talk about the potential now. All the way up here, they had 400 joules of potential. C is halfway up, right? 2 meters instead of 4. So we're going to have 200 joules of potential at point C. So that potential energy is 200 joules. Now we know the total energy has to be 400 because energy is conserved, it's always 400. So let's look at that internal energy, that Q value. Well, we had 200 potential, 100 kinetic. Well, that's only a total of 300. So how much turned into internal energy or got lost? I'd say 100. Now our numbers match up because we had like 200 and then 100 and then 100. That's a 100, come on. 100, that's a total of 400, right? 2 and 1 and 1 make 4. I'd like you to try E and F now. So pause the video and try these on your own. And you're going to use this information down here to help you answer those questions. So again, pause the video and give this a shot. Hopefully you tried them. At point E, the skateboard has 200 joules of kinetic energy, so I'm getting that from here. Alright, so this is point E, so 200 joules of kinetic. Oh, God. There we go. Let's just make this wider. And then we know that the total has to be 400. Because the total energy is always the same, so it's always, always, always 400. I'm even going to fill it in for part F. There we go. Alright, so let's go. At point E, E is all the way in the bottom here. Well, if you have no height, then we have no potential. So I'll leave the potential blank. And when we look at our graph, there's like energy missing, right? We've got 0 potential, 200 kinetic. What's the leftover that must be internal? Well, it has to be 200. 200 and 200 make a total of 400. Alright, point F, which is right here. At point F, the skateboard has no kinetic energy, so I'm going to leave that blank. Point F is about halfway up the ramp, or exactly halfway up the ramp. It's 2 meters compared to the top of 4. And so it'll have half of that 400 in the form of potential. But again, no kinetic. If we look at this, energy is missing. We had 200 potential, no kinetic. That means the internal must be 200. Again, 200 and 200 make 400. Internal energy. So, let's have you try a couple of these problems. If you can do 40 and 41, that would be great. I'll pause the video to give you a chance to try it. So, again, just pause the video, give this a shot. Alright, I'm hoping you paused the video and looked at it, so let's go. A bowling ball has 500 joules of potential energy at the top of ramp. So we've got this ball at the top of ramp, and it's going to go down. This is our ramp, and it's going to go to the bottom of it. It has 500 joules of potential at the bottom. So at the top of the ramp. So all the way at the bottom, it should still have 500 joules of energy, but I don't think it does. I think it only has 400. We definitely lost energy along the way. How much energy did we lose? Well, to figure out the difference, I'm just going to subtract these two. 500 minus 400 gives you 100 joules of internal or lost energy. So that energy is still there, it just went into this heat, like this wasted type of energy. 41. 5 kilogram bowling balls dropped from the roof. I think that says roof. Yep, roof of the school, which is 10 meters above the ground. How much potential does it have? I think we have an equation for potential energy. And as always, here comes my reminder that you have these equations on the last page. Alright, the mass was 5. We know that because mass is measured in kilograms. We know that G is always, 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 always 10. And then we are 10 meters above the ground. That sounds like a height to me. 5 times 10 times 10, I believe that is 500 joules of potential energy. 500 joules of stored energy just waiting to get released by falling to the ground. So let's say we do that. For part B, if the ball hits the ground with 350 joules of kinetic, how much internal energy is created during the fall? So we start with 500 joules of energy at the top. Oh god, I think it's an extra zero. Yeah. Let's just erase it. Alright, 500, this is going so bad. 500 joules of energy at the top, and it's going to fall down and then hit the ground down here with only 350 joules of energy. Alright, so how do we figure out the energy that got lost? Well, we can subtract it. 500 minus 350, I think that's a total energy of 150 joules that got lost. And that's it. So that's our internal energy. It's energy that's lost. And for the most part, we'll just find it by just figuring out the missing part. Figuring out what's missing by using subtraction.